Hi everyone. So today, lipoproteins is a very hard topic to explain. So I will try and do my best to help you guys with lipoproteins. All right? So first, let's start off with the three basic things that we all should know: chylomicrons, HDL, and VLDL. So we need to ask us, or these questions that you should be asking yourself, right, is where do they come from, where are they made, and how they interact with each other. So let's get this done and let's get this started. So our chylomicrons, right? Let's start off with that. We should first understand that they are being made in our intestines, right? Once you guys have this done, then second thing is which protein do they need to be released, right? That protein, my friends, is going to be ApoB48, okay? So this is the second thing. It's going to have ApoB48, right? On the contrary, our VLDL, they have ApoB100. 100 is longer than 48, so VLDL is like very long. So VLDL, ApoB48, right? So now we talked about chylomicrons. Let's move into our VLDL and see what these guys do. VLDL are produced in the liver. Two, as I mentioned, they need ApoB100 to be released. Are we clear so far at this point? Now, let's move into our HDL. So, HDL is produced by adipocytes and our myocytes. Alright? HDL produced by adipocytes and myocytes. And what are some of the things that HDL actually has? Number one is going to be ApoA1. That's the main thing. That's the only lipoprotein that has ApoA1, and that's going to be your HDL. And it doesn't stop there. There are some more things. We also have our ApoC2. And I would like to add that ApoC2 activates LPL, okay? Our lipoprotein lipase. So just keep that in mind. Then we have our ApoE, also very important. Now, I would hope that we are done at this point, but no. There's a fourth thing that HDL has, and that is your ApoC3. Wherever you have an activator, you will also have a lipoprotein lipase inhibitor. So your ApoC3, that's the inhibitor. So keep that in mind. So now we have the three things: chylomicrons, HDL, VLDL. We now know where they're made, and we now know what kind of proteins, lipoproteins they start off with. Now let's start with chylomicrons and see how it progresses. The first thing that you guys should know is chylomicrons are released into our lymphatics. So if this is my chylomicron, it's going to be released into my lymphatics. Then it enters the blood. And at which level does it enter the blood? At the level of the thoracic duct. Perfect. On its way, chylomicrons interact with HDL, and they receive three things from them. They will receive your ApoC2, ApoE, and ApoC3. and now your chylomicron will be all jacked up, right? It's gonna have all of these things, and in this analogy, I think like it gets all jacked up, and it will have, your chylomicron basically is on steroids now. It's all jacked up, it's all beefed up. So this is how your chylomicron will now look. With these little muscles. Oh yeah. Chylomicron is happy. As it travels through the blood, it's gonna interact with your lipoprotein lipase, right? Now, keep in mind that lipoprotein lipase is found in the highest concentration in the heart. So as an example, we will say that this is in the heart. And in the heart, it's so much lipoprotein lipase. Think of this as your chylomicron is dipping into a pool of lipoprotein lipase. When chylomicron goes inside lipoprotein lipase, your ApoC2 will activate LPL, lipoprotein lipase will cleave all the tags, right? So when they cleave off all the tags, actually they will not cleave off all the tags, because at a certain point, a certain protein is going to tell LPL to stop. You've done enough damage. And that's going to be your ApoC3, which is the inhibitor. Okay? So LPL will do some damage, but not enough. This guy is going to come out looking something like this. Like a little zombie of his former self. And that's called a remnant. Chylomicron remnant. So this guy is going to be your CM remnant. The main thing is your E. All remnants are taken up by the remnant receptors, and remnant receptors recognize ApoE. So this guy will be taken up by the liver, and it recognizes ApoE. Perfect. So we are done at this point. Now let's move on to our VLDL. Same thing. Our VLDL enters the blood. Wrong marker. I like to keep everything organized. So, VLDL enters the blood. Again, HDL is going to try to trick it and give it three things, which are going to be your ApoC2, ApoE, and ApoC3. And again, just like your chylomicron, your VLDL will also be jacked up. It's going to look like it got everything. It gained all that strength that HDL gave him. Now, at this point, when it circulates in blood, this also interacts with lipoprotein lipase, right? So when this interacts with lipoprotein lipase, VLDL becomes IDL. IDL, right? Once again, remember that LPL, activated by ApoC2, inhibited by ApoC3. Also, LPL, I forgot to mention, are anchored in your blood vessels. By what? By gags. Okay? So these guys are anchored by gags. Keep that in mind. Now, IDL. Two things can happen to it. Let's start off with the easy one. IDL is a remnant of VLDL. So, it will go to the liver, be uptaken by your remnant receptors. And what did I say about remnant receptors? They recognize ApoE. Perfect, right? Now, let's look at the second thing that can happen. As it goes near